Okay, so now we're on to a new problem, and I just knocked myself out of order. Okay, so we have a problem now that relates to a question I've asked you in the quiz. I hope that you are taking the quiz and then looking at the answers to the quiz. I didn't realize that Nearpod wasn't telling you what the correct answers were. And so for our sort of conceptual quiz questions as part of the lecture, it only really works if you can see what the accepted physics answer is compared to your first sort of go at it. So you need to be reviewing those questions and the correct answers and kind of comparing your answer to the correct answer as you go. I have no way to test that for you, and I don't know how to make Nearpod tell you what the answers are yet. So I have some more research to do about Nearpod before it works seamlessly, but I think so far we're doing okay with Nearpod. So here we go. A flatbed truck is carrying a heavy crate. The coefficient of static friction between the crate and the bed of the truck is 0.75. What's the maximum rate at which the driver can decelerate and still avoid having the crate slide against the cab of the truck? Okay, so we are not really concerned with the truck. We're only concerned with the crate. So let's say that the crate and the truck are moving to the right. They're going, driving to the right. So if the driver slams on the brakes, what direction will the friction be? So I'm imagining going to the right and slowing down. If I go to the right, my inertia is keeping me going to the right. If I'm going to slow down, there must be a force pushing me to the left. So the force of static friction between the crate and the truck needs to be to the left in order to keep the crate with the truck decelerating. Kind of counterintuitive, but the crate and the truck are moving to the right. The force of friction between the cars or the truck's tires and the ground is going to also be to the left. Everybody's got to have a force pointing to the left in order to be moving to the right and slowing down. So that's my first argument, that the force of friction, static or kinetic, will be to the left. Then I've got, of course, the support force of the bed of the truck on the crate, and then the pull of gravity of Earth on the crate. And these are almost all three look like they're the same magnitude, but the only ones we know that are actually in balance are the normal force and the pull of gravity. I'm expecting that the acceleration in the y direction should be 0. The crate should stay sort of level with the bed of the truck, even if it's sliding. So the net force in the y direction should be 0 newtons, and that means the normal force should be equal to the pull of gravity. Let's see, do we know? We don't know what the mass is, but we can just say that's mg, right? So we have some way to talk about that normal force in terms of sort of fundamental stuff. Okay, so what is the maximum rate of acceleration? So max acceleration for the crate to still be stuck, so stuck with static friction to the bed of the truck. It's a bit counterintuitive, but these are the only three forces acting on the crate. There's the push up of the bed of the truck that's supporting the crate. There's the downward pull of gravity. And then because the bed of the truck is pushing on the crate, there is this force of friction, but nothing else is touching the crate, unless there's something strapped down or whatever, but that's not part of this problem. So the force of static friction becomes maximum when it's equal to the coefficient of static friction times the normal force. And that maximum static friction occurs at the maximum acceleration. So acceleration is maximum when the net force is max divided by the mass. And the net force is max when the force of static friction is max. That needs more space. But the acceleration is maxed when we have max static friction. Max static friction occurs at mu sub s times normal force. dividing by the mass of the crate. Max acceleration is equal to mu sub s times normal force, mg, divided by m. And so surprisingly enough, and this hints at another of those quiz questions, the mass itself is irrelevant, even though the normal force influences the actual force of static friction. If we're talking about acceleration, the acceleration depends only on the coefficient of static friction and acceleration due to gravity. If it's not horizontal, it's more complicated. We'll have to worry about the angle of inclination. But for something that's level, we're only concerned about the coefficient of static friction and the acceleration due to gravity. Strange but true.